Good afternoon, ladies and gentlemen of Algebra 2 Honors. We started on this next exercise sheet here, which was problem 13. And what I'd like you to do is do problem 14, and then we will choose somebody to help us out with that. Can you do that? Or had anybody work out 14 already? No? You're going to work on it now? Okay. And remember, what are the steps to working these out? Do what first? Least common denominator, but even before that. Factor, if you can, right? Then the least common denominator. Then Ben, I think, mentioned excluded values, right? That's helpful because we're going to need that to check our answers. And then, so you know what to do. Then, what do we do with that least common denominator? Multiply the equation by our least common denominator, and that'll be it.
I got 3. X minus 3 is minus 2. X minus 3, which is 3. X minus 1, and then X minus 2. This doesn't look right.
Oh, because you only have to write it once.
Well, this was under it, so I'm getting lost in my word. Lost.
How are you doing, Kim? You doing okay on this?
I don't know.
You don't know? What do your friends around you say?
I think I'm almost there, but I'm just, there's not enough room.
Oh, so you're just trying to take it in? You don't have enough room? So you're telling me that your engineering handwriting is failing you?
Yes.
That's one thing when I was doing these things, I was able to write really small. Yeah, the way it's side by side there, it's sort of a long thing. I see what you're saying.
I can move down here. And
Oh,
then
okay,
down there.
yeah. Well, fortunately, we're not gonna need very much space for this one here. Yeah, that's not gonna help us up there. How are you doing, Julia?
I'm not gonna even put
So low loss on the front part, and then
What is that?
and then about
2, 1, and 3, right?
You see how much?
1, and 3 times, I don't know.
Now Marcus has the small handwriting.
Yeah.
3 would be 1?
You got the engineering writing. Yeah, that's right, I know. Gabby's right. If you miss a day, sometimes it can throw you off.
Yeah, Gary, why we're here?
water reasons before.
First, okay, we took our phases.
And we talked to, then went to the eye doctor, then went to, so it wasn't gonna be as fun.
That's kind of like flexible.
Yeah, so good.
They just, the title of the first.
So yesterday Gabby was just too busy for us. That's okay. We'll just, she had a lot to do.
For what your eye doctor.
Okay, we have 3 candidates left.
Oh my gosh, you didn't need.
And the candidate we have is Gabby.
Can I read it? Okay, we can. Actually, I would do that. No, you could. Actually,
So Gabby, were you able to find like a least common denominator and stuff like that?
Yeah, I found the least common denominator.
Okay, well then go. Let's just work with it. You'll be good.
So I factored out the x squared minus 3x plus 2. I factored it out to x minus 2, x minus 1.
Okay, so you got this x squared minus 3x plus 2 is equal to x minus 1, x minus 2. That was,
Yes.
okay, there we go. We got that. Okay.
And then the 3x minus 3, I factored out to 3x minus 1.
That's 1. Okay. All right.
The
Least common denominator.
denominator is 3x minus 1, x minus
3 times point x minus 1, x minus 2, right? So does this look like a good least common denominator, everybody?
yes.
Okay, go ahead. What next?
Then you think times the least common denominator by the numerators.
Yes, let's do that here. We have 5 over, we have, this one here was x minus 1, x minus 2, right? And then we have to multiply that by our least common denominator, which is 3, x minus 1, x minus 2. And then so we have minus 1 over x minus 2, and that's going to be multiplied by 3, x minus 1, x minus 2. Is that right, Gabby?
Yes.
And then we have equals. We have x plus 6 over 3 times x minus 1. And what is this multiplied by? Least common denominator, which is 3 x minus 1 x minus 2. All right, what next?
And then you just times them all together, so it'd be, would it be 15 x squared minus 2? Or is that not?
No.
Or do you
Okay,
have
so
to-
let's remember why we multiply by the least common denominator, right? We did it so we could cancel out everything in every denominator, right? Are we able to cancel out everything in every denominator with this?
Yeah.
Yes. And if we're not able to cancel out everything, what does that tell us?
There's something wrong.
That's probably something wrong with our least common denominator. So let's go ahead and do this. So what cancels out here?
X minus 1.
Okay, so that's 15, right?
Yeah.
And what cancels out here?
X minus
And so we have minus 3, x minus 1, okay? And then the last thing is what?
3x minus 1.
So 3x minus 1 cancels out. And now, what do we have left? X plus 6, x minus 2. All right? What next? No, okay. What we're doing now is we're going to solve for x. What we've done here is we've cleared the denominator, so now we have everything in a single numerator, which we're going to be able to solve using either a linear equation or a quadratic equation. I think this one's going to be what kind of equation? A linear or quadratic equation? Okay, Jay says quadratic, questioningly. Why is this going to be a quadratic equation? He's right, by the way. Why is
It's
it
going to
going
have the x squared of x and the single
to?
number.
You can have the x squared, right? So anytime you got x squared, quadratic. So let's go ahead and expand out and distribute. What do we get when we distribute out here? We get 15. What does this become here?
3x minus 3.
Negative 3 times x.
Negative 3x.
Negative 3 times negative 1
Plus 3.
plus 3. And then we go ahead and distribute this guy out here. Okay, let me show you this. We got x squared, we know that. And then we got plus 6x minus 2x is going to be what? 4x. And then we have 6 times negative 2. We have 12. Okay, what next? Yeah, combine 15 and 3, so we got plus 18. So x squared plus 4x minus 12. And what next?
Subtract from different sides. I forgot what it's called.
Yeah, so Julia's saying subtract from both sides. So most of the time when you solve quadratic equations and even linear equations, or you can do it possibly too, especially quadratic equations, you want to set one side of the equation equal to 0, thank you. And how would be your way of setting this one side of the equation equal to 0? Okay, how about plus 3x minus 18? And then over here we say plus 3x minus 18. And we have 0 is equal to all this here, x squared plus 7x minus 30. And we'll go ahead to the right here. So we get 0 is equal to
X plus 1 minus 3.
Okay, x plus 10, x minus 3. Is that going to work out? Yeah, because that's 10x minus 3x. That's going to work out. So what are our solutions here going to be? X is equal to?
-10.
Thank you, Gabby. And x is equal to? 3. And are these real solutions or extraneous solutions or what? Do we have, what is our, we didn't put our excluded values here, did we?
No.
Let's go ahead and do that quickly and compare. What are the excluded values going to be for this function? Not equal 2. This could not equal 1. And then we look here, are these the same as any excluded values? No. So these are what we call real solutions. Okay, now what we're going to do with the remainder of class time is work on 15 on, and owing to time, we're not going to be able to get through all of these, so we're going to probably do maybe 2 or 3 of these, depending on how much time we have. And I had a student in 7th period, you might know him, Brian, who looked at problems 15 through 20 like this. Come up on me, please. Come up someday, sometime today. So, it's just like I got too much loaded on this computer.
It's the notebook's not very smart.
Brian would, and Brian's the one to give me a hard time about this. Oh, you need more RAM, you need a newer computer, more RAM in your computer. So he'd give me a hard time about this. There it is. So here it is. And problems 15 through 20, we have come to what we call Hell's Library, story problems. And really, when you get to these story problems, you're really looking at applications. And to me, there's really a quantum leap of rigor and difficulty, especially. Now, some story problems are easy. To me, rational functions, to make that's pretty advanced. I mean, so we're going to look at these today, and I elicit your help as much as possible. We're going to talk our way through these problems, starting with problem 15. Okay, a save percentage of cross is found by dividing the number of saved by the number of shots faced. The cross goalie saved 9 of 12 shots. How many additional consecutive saves S must the goalie make to raise his save percentage to 0.85? So for this problem here, how would you, what do you think about that problem? The way it's written? You notice anything about it?
Ratio.
Ratios, right? So you have a ratio, so you know it's a ratio problem. Okay, I'm gonna tell you something else about this, is there are mistakes in the writing of this problem. And I want you to tell me where those mistakes are, just in the writing of the problem.
Is it the total shots? Letter?
The letter?
It mentions the consecutive saves is S, but it doesn't mention like the total shots.
Okay, yeah. I don't think that's going to be a problem with that problem. I don't think that. I think now, one thing about S that I just don't like, I don't like to use S as a variable if I can help it. Why not?
Looks like Todd.
Looks too much like 5. It does. So that's why I don't like using S, but they gave us S, so they force us to use it here. But what's wrong with this problem? It's not the S.
Is 0.85 going to be exact?
Well, it may or may not be exact, right? Doesn't give us information if it's exact. That's a possibility. I think if you eventually, it says set up, do not solve, write a rational equation, but if you actually did solve it, I think you would end up with,
The original part?
okay, well, I don't think so. That's not right, but that's not what's wrong with the problem. Okay. What is wrong with this problem?
Oh, percentage. You gotta,
Percentage,
it's
yes.
assuming that you were doing percentage.
Oh.
Yeah, so what this is, yeah, so Ben, yeah, so what we have here is, yeah, so a save percentage across is found by dividing the number of saves by the number of shots faced times 100, right? And then it says, last one, how many additional consecutive saves must the goalie raise to mark save percentage to 85%? So now it's a corrected problem. Okay. Now this is a real world problem that I had a student, I forget, it was a couple days ago, Marcus, in second period, who said, well, what's the real world use of this? Well, you could use the same concept if you had to figure out if you had somebody playing, we don't have like a softball player, but if you had somebody that needed to raise a batting average to a certain level, you could figure out the same way. How many hits in a row are you going to need to get to raise your batting average from 300 up to 320, right? Similar sort of thing. And anybody have any ideas about what an equation for this would look like? Rational equation? Okay, we know we have 9 shots over 12 as our starting point, and we're going to add S to both the numerator and denominator, and we're going to raise the save percentage to 85%. So now we have to put this back in decimal form. And now we have an equation that we could solve it says set up, do not solve, but you could actually solve that equation, right? So that's it. And I think if you actually, I want to just go to this now, I think the actual number for this, for S, I think it's 8. That makes sense, because if you have 7 plus 8, that's 17. Or 9 plus 8 is 17, and the denominator 12 plus 8, that's 20. 17 over 20 is 0.85, right? Okay. We're going to skip number 16 and go straight to 17, geometry. We got a new skating ice rink, approximately rectangular in shape, and it'll have an area of 18,000 square feet. It says using an equation for the perimeter P of skating rink in terms of width W, what are the dimensions of the skating rink if the perimeter is 580 feet? How would you do this problem? What do you notice about it? What do you have to consider about it?
You got another formula.
Yeah, I got another formula. So let's go ahead and look at the formulas. We're going to find length and width. And we're going to use here, we got width here. So what are the formulas we need to use here? What did you say?
Area.
So area, so Julia says area. So area is going to be equal to what? So length times width. And they're telling us that it's approximately rectangular in shape, but for the purpose of this problem, we're going to have to use Okay, and we have, in this case, we know our area is going to be 18,000 square feet is going to be equal to our length times width. Now from this equation alone, can we figure out what the length is or what the width is? No, we can't. So we have one equation and two unknowns. So we're going to need to have another equation going for us somehow. What is that going to be? So perimeter. So Gabby says perimeter. So we have perimeter. And what's our formula for perimeter?
Length, what?
Yeah, so
2L plus 2W?
so Jay said it here. I want to go ahead and put it the way Jay said it because it's going to make it easier to work. It's 2L plus 2W. And we also know that that's going to be 580 feet, right? 580 feet is equal to 2L plus 2W. But in this second equation, can we solve this one here? The second one? No. Okay, now, can we simplify this equation here any though? Yeah, what can we do to simplify this equation?
580.
Yeah, so if we divide everything by 2, I'm going to go like this. I'll put /2. We're going to get 290 equals L plus W, right? Okay. What's our next thing to do in solving this equation?
Subtract either.
Rational equation.
Okay. We're going to use a substitution method of solving, and what we're going to do is we're going to use substitution to get rid of one of these variables here. How do we do that? How do we get reduced to one variable here? Well, I'll show you. What we're going to do is I'm going to solve for L. How do you solve for L over here? L is equal to what? 18,000 over W. So now what can we do with that L? Right over here. So we get 290 equals 18,000 over W plus W. And so now do we have one equation, one unknown?
Yeah.
Yes, we do. So let's go ahead and find out a couple things. What's going to be our least common denominator for this? It's going to be W, right? What's going to be our excluded value? Excluded value.
0.
W cannot equal 0, right? Not defined. So what are we going to do with our least common denominator that we've done in all the other problems? Multiply, right? So let's go ahead and multiply by W. So on the left side we get, I'm gonna work this out. We've got 290W equals 18,000 divided by W times W. That's going to be 18,000, right? And we have plus W squared. Okay, what's our next thing, or how we solve this? Subtract, right? If we subtract 290W, we get W squared minus 290W plus 18,000 is equal to 0. right, can you think of some numbers we can use that when multiplied together are going to be 18,000, but when what are going to be the two numbers, two factors here of two numbers that multiply together equal 18,000?
290.
So let's do 290.
About to say that, Dan.
So we have W minus 200 and W minus 90, right? So what does W equal to? W equals to, we have 90 and 200. So what's going to be the length of this, actually?
200.
So 200. So we'll say W equals 90 and length equals 200. And what are the units here going to be? Feet. Okay, so that's going to be are these real solutions?
Yeah.
Because they are not a what? They're not an excluded value. Okay, last thing I want to do in class is, we do have a few minutes left. I want to skip another one and go right to number 19, where you have the riverboat problem. And we probably don't have time to actually go through and solve this, but I do want to set this up. So you got the riverboat travels at average speed of 14 kilometers per hour, still water. Riverboat travels 114 kilometers east up the Ohio River, 110 kilometers west down the same river, a total of 17 hours. So that was back in the days of a steamboat, and I think that's what, I think Abraham Lincoln actually was on the Ohio River. This went down all the way to New Orleans. Anyway, so what are we going to have? What's going to be our variable here? Okay, what was the speed of the current river? So we're going to call C equals speed of current, right? Okay, and what is our equation that we're going to set up here? Okay, time to go upstream is going to be what? It's going to equal to, we got 110 kilometers, so it's going to be 110. Okay, what we're going to have is, okay, we're going to have 14, and we're going upriver. Are we going faster or slower? Slower, right? So 14, let me get, I think I got this wrong. 14 minus C, I think C, yeah, it'll be 14 minus C.
Yeah.
And for time downstream, what is that going to be?
110, 14 plus C.
That's going to be equal to 110 over 14 plus C. And so what is our equation that we set up with 17.5 hours? Well, we have to add these two.
It equals 17.
So we get 110 over 14 minus C plus 110 over 14 plus C. And we know that's going to be equal to 17.5. Okay, what is going to be our excluded value? C cannot equal,
Plus or minus 14.
C cannot equal plus or minus 14. And we know that minus is really not an option. And so what's going to be our least common denominator?
14 minus C. Multiplied by 14 plus C.
14 minus C, 14 plus C. And then if we multiply this whole thing by this, we're going to be able to solve. So I want you just to turn this in. I might just go ahead and solve that tomorrow. We're going to start doing test review tomorrow. So I'm going to save this for now so we can kind of come back to it and just look at it. And yeah, we're going to have for 3 days and everything, so I'll be good.
margin